Hello everyone. Today we are gonna be learning about recursion. So what is recursion? Recursion is simply when a function or procedure calls itself. Now guys, that function or procedure is known as a recursive function. Now guys, an importance of recursion is it is effective for tasks or problems that can be naturally divided into smaller, manageable subproblems. Some examples of these are mathematical calculations such as the factorials, Fibonacci sequences, sorting algorithms like quicksort and merge sort. Now that we understand that, guys, let's start demonstrating recursion with some examples in code. Alright guys, so let's get started with our first example. So for our first example, we will simply create a function called count, which will accept an integer n and count from 1 up to n. We will do this both iteratively and recursively, and then we will see the differences. So let's create our count function iteratively. So let's do a void count, and it will accept a int n, and we'll say for int I equals to 1, I is less than or equal to n I plus plus, and let's do a printf counting modulus d new line I, and let's test out our count function, and we'll pass in 20 because we'll count up to 20, and let's see our output. So you guys can see we counted up to 20. Now that was our iterative approach. So let's do our recursive approach now. Alright guys, so let's do our count function recursively now. So we will simply do a printf counting modulus d new line n, and then we will need to call our count function with a parameter of n minus 1. And let's see what happens. So you can see guys, it's calling our count function repeatedly or indefinitely. And then we get a segmentation fault, which is a crash within our program. So why did that happen? That's because we need to add a condition which is called a base case to our recursive function, which prevents our recursive function from calling itself indefinitely. Now, the actual reason why our program crashed is because whenever we call a function, it gets added to something that is called a call stack. And a call stack under the hood is a stack data structure, which when invoked uses memory within our computer program, and then whenever that memory runs out or gets too big, a stack overflow happens, and that causes our program to crash because it ran out of memory. Now let's solve the issue of our program counting indefinitely. So let's do a if n equals to 0, which is our base condition or our base case. Then we will simply do a return, which will cause our recursive function to exit. So let's recompile our code, and you guys can see our recursive function now stops running indefinitely. But the issue with it is we want to let it count from 1 to 20. So why did that happen? Remember guys, a stack data structure can be used to reverse things. Now, each time we invoke a function, it gets added to a call stack, which simply gets called in reverse order, right? So first it called 20, and then it called 19, then it called 18 within our count function, etc. So what we need to do is move our print function down below where we're calling or invoking our count function, and that will solve our issue. So you guys can see now, our program is working just like we intended it to do. So you guys can see, we did it, but we can compare our iterative approach now with our recursive approach. For a simple program like this, guys, I would generally prefer the iterative approach over this. Because look at this, it's just a loop and it's much more simpler than doing this recursively. And it doesn't use a lot of memory, which caused our stack overflow or segmentation fault. Now guys, let's move on to another example of recursion. Alright guys, so for our next example, we will simply create a function that will print digits in reverse order within a given number n. So let's do that. Iteratively first. So we'll do void print digits underscore reversed, and it will accept a integer n. And we'll simply do a while loop, so we'll say while n is not equal to 0, then we'll simply do a printf modulus d, new line, and then we will print out n modulus 10, so we can get the last digit of our integer n, and then we'll simply divide n by 10 within our loop. So let's test out our iterative function now. So we'll call print underscore digits reversed, and it will accept an integer. Let's give a integer like, let's say 347, and let's see what happens. So you guys can see we get 743, so it reversed our number. Now let's do this recursively. Alright guys, so let's do this recursively now. So here we have our print digits reverse function, which accepts the parameter n. We will simply do a printf modulus d, new line, comma n modulus 10, so we get the last digit, and then we will call our print digits reversed function with the parameter n divided by 10, and then let's see what happens now guys. So you guys can see it's running indefinitely, and we get a segmentation fault. Now let me ask you guys this question. Why did that happen? That's because we need to add our base case in order to prevent our recursive function from running indefinitely and causing a stack overflow. So let's add our base condition or our base case. So we'll say up above here, we'll say if n is equal to 0, then we will simply do a return, which will exit our print digits function. And now guys, you can see it reversed our digit. What if we added our print statement below here? Let's see what happens. You can see it printed 347, so 347. Now why is that? Because remember, a stack, whenever we call a function or call stack, or functions get called in reverse order. So whenever each one of those functions gets popped off the stack, we will get left with everything in reverse order. So in order to keep everything within the right order, so we can print it or number in reverse order, we need to ensure that our print statement is above here before we invoke our function. And now it's reverse, so 7, 4, 3. So now guys, that we understand recursion, here's a summary. Recursion is the process of a function or procedure calling itself. Now this function, guys, is known as a recursive function. Some problems that are done using recursion can be done iteratively, but they both have their disadvantages and advantages. Some advantages of recursions, guys, are simpler code for complex problems, code readability, problem decomposition, meaning breaking down problems into smaller subproblems, backtracking, ideal for problems that involves exploring all possibilities such as puzzles and mazes. Some disadvantages or memory overhead. Like you guys saw, we had a stack overflow if we didn't have our base condition within our recursive function. 2, slower execution. 3, harder debugging. 4, risk of infinite recursion, which caused our program to crash earlier, guys. So I hope you all learned something valuable. Thank you guys for watching, and I'll see you in the next DSA episode.